We're going to talk about circumscribed angles. We're continuing our angle measures in a circle. So what is a circumscribed angle? So back to our guided notes. You can fill this up now. The circumscribed angle is formed by two intersecting tangent lines. And the vertex is outside of the circumference. It means it's outside of around the circle. It's right here. Now, if we're like, wait, what is a tangent line again? It's a line that intersects the circle at exactly one point. So only touches one time. So that's what a tangent line is. And this is the formula for it that we're going to talk soon. It's a difference of the intercepted arcs divided by 2. Okay, so on the formula sheet here, we talked about on the vertex, inscribed angles, and quadrilaterals. If the vertex is inside, now we're going to talk about what if it's out. So if the vertex is out, like it just said on the other paper, last time we added and divided by 2 if it's in your vertex. If it's out, you're going to do the difference instead. So if it's out, you're going to take the difference. Oh, there's a gnat. Difference of intercepted arcs and divided by 2. And where is that located? That is down here. So the vertex is outside. So you take half to find angle A, take half of the larger arc minus the smaller arc. Same thing here. Intercepted arcs, angle A. The large arc subtracted from the minor arc. So major and minor arc. Large and small arcs. And here your vertex is out there. So you're going to take half of the major arc minus the minor arc. Okay, so no matter what's intersecting, a tangent line on the exterior, the secants, whatever, if your vertex is outside, that's what we're going to be doing. So let's go on to our examples here. So I'll just write it again here. It's the difference of intercepted arcs. And we're going to divide that by 2. So you're taking half of it. So last time, if it was in, it's the sum, means you're adding. If it's out, it's going to be the difference. Okay, so think about it. In and out are opposites. So the opposite of adding is subtracting. So that's what you're going to be doing here. Okay, so it says find measure of angle S. So if I was just approaching this problem without realizing if it's a circumscribed angle, I'm just going to look at it. I need to find my angle. It's right here. And that's my vertex. So because my vertex is out, I'm going to subtract the intercepted arcs and take half of it. So you always take the major arc first. So you're going to do 179 minus your minor arc, 71 degrees, and then you're going to divide that by 2. Okay, so you're going to get 108 divided by 2. So that means the measure of angle S will equal to 54 degrees. Okay, next. I want to find the measure of angle W. Okay, so right now all I know is that this is 106 degrees. I don't have my major arc. So how do you think we'll find that? So think about it again. A circle, a whole circle complete is 360. So to find out what the other rest of this circle is equal to, we're going to do 360 minus 106. And that's going to give me this big arc over here. That's going to give me 254 degrees. So this whole thing now is 254 degrees. I do not like how I wrote 254. So 254 degrees. Okay, so now that we have the intercepted arcs, I have the minor arc and now I have the major arc. So because the vertex is outside, you find the difference and take half of it. So the major arc minus the minor. Take half of it, divided by 2. So that's going to give me 148. Divide that by 2. So the measure of angle W will equal to 74 degrees. Okay, and the last one, we're trying to find the measure of arc CD. I want to look for this arc. So you're not looking for the angle now. My circumscribed angle is 56. So remember, for me to find this angle, I have to find the difference of intercepted arcs and divide it by 2. So I'll just set it up here. So let's say A. To find my circumscribed angle, all I have to do is take the difference of intercepted arcs and I have to divide it by 2. Okay, so we'll slowly input our values. So my circumscribed angle, it's already given, is 56. Now I want to find the difference of my intercepted arcs. So remember, it's always your major arc subtracting from the minor. So my major arc is right here. I don't have anything, so replace it with a variable. So I do x minus my minor arc, which is 95, and then I divide it by 2. That's essentially what we did all on the top questions. You always have to find your circumscribed angle. You found the difference of the major minus the minor, divided by 2, and you get your circumscribed angle. So now we're going to go ahead and solve. I want to solve for x, but right now it's in a fraction. It's trapped. The denominator is 2. Think about what operations is going on. So this is being divided by 2. So we're going to perform the opposite operation. That way we could remove this fraction. So I'm going to go ahead and multiply both sides by 2. Because these two, no pun intended, okay, they're going to simplify out. So bye-bye. That's gone. So now you're going to do 2 times 56. That gives me 112 equals x minus 95. So now there's no more fraction to worry about, and now it's your one-step equation. So you're solving for x. So that means I want x to be by itself. I see subtracting. I do the opposite. I add 95. So when you add that, you're going to get x equals to 207 degrees. So that means my arc, the measure of angle CD, is going to equal to 207 degrees. So I need to find that out. So whenever you're looking for angles in a circle, always determine, is my vertex in, on, it's better to say, is it on? So you take in or out. If it's on, you take half of the intercepted arc. If it's in your vertex, you add them divided by 2. The opposite of in is out. The opposite of adding is subtracting. So you're going to subtract the major arc minus the minor and divide it by 2. Okay, so this is how you solve for angle.